Now I'd like to welcome Matt and Pranos from Mayo Clinic to discuss Mayo Clinic's blueprint for hallucination-free multimodal AI.
So Panos and I are going to talk a little bit about Mayo Clinic's journey, generative AI broadly, and specifically this questionation of hallucinations and how we deal with them at Mayo. The generative AI program at Mayo was started in, let me see if I click this correctly. Look at that. There we go. Generative AI program was started at Mayo in the summer of 2023. The organization was really created, OpenAI launched ChatGPT in November of 2022, that time frame. Everybody was reacting to the generative models and those chat frameworks at that time, and the potential was percolating for everyone. The Mayo Clinic has a long history with machine learning and artificial intelligence. Panos has been involved in that in the radiology department for many years, many algorithms that have been deployed over those years. But this new technology really was something that the organization thought we should put significant effort into experimenting with, learning from, understanding the potentials and the risks associated with that. And so the organization was created to do that. There were really two large mandates initially. The first was the reduction of administrative burden. When you're thinking about overhead for a clinic visit with a patient, a lot of that overhead is involved in documentation, search, preparation and summarization of patient histories, understanding who that patient is that's coming in front of you for that visit. And then also, how could these models be applied to improve clinical practice? So if you're thinking about improvements in diagnostic medicine, improvements in the different modalities, whether it's pathology or radiology or laboratory medicine or other areas where we could actually apply this technology to improve care for our patients. Those were the two big umbrellas. Early on, there was a lot of work done related to summarization and trying to see how we could take that patient's electronic health record and create concise summaries from it, either related to their summarization that might be written by a clinician at the end of their visit, or summarizing that patient so that you can prepare to go in and see them at the beginning of the visit. And these were the types of tasks that we engaged in early on. And I think oops, I didn't really follow our slides well, did I? Talking about some of the algorithms that have been deployed and how many over the period of time, and then really looking at how we can do that safely. As we think about these algorithms, the concern, as all of you know, is hallucination. So it's in some domains, if I'm doing a creative writing paper for high school, it's okay if there's a little hallucination involved, and there's a debate about hallucination and creativity and the relationship between them. So that's all good. If I'm actually preparing to see a patient and their life is on the line and it's at an organization like Mayo Clinic, where the level of care and the excellence that's expected of us is at an extremely high level, not so good to have hallucinations when you're preparing those summaries or for before or after the visit. And so that's really where I will hand it off to Dr. Korfiatis to talk a little bit about how we've tackled that over time.
Thank you, Matt. So as Matt pointed out, the program was created about 1.5 years ago. We have a longer history when it comes to building AI and actually monitoring AI in production. So as part of the work that I'm doing in radiology, we are doing post-production monitoring for all the commercial FDA-approved algorithms that we are using. And one thing that it was obvious to us. Radiology went through like this hype a little bit, like earlier than Gen AI. Is these algorithms fail and fail in unique ways, so we have to like figure out how to ensure that our patients are in the forefront of our focus, and like our doctors use the best tools, correct? So when we started thinking about summarization, there were two main issues, correct? There is like, I guess, like, like three, if you kind the hype, correct? There was like, yeah, this tool is going to work. But then when you start digging in the use cases, you like start seeing that the model might hallucinate, or in some cases, it is missing information. There are like solutions that we are trying to apply for both cases. But imagine like having like these amazing doctors that now want to spend more time with their patients. They don't care documenting or like going through like the patient record. They want to like have a better interaction without like being in their computer, focusing on what is in the screen versus like looking at the patient. Have these people excited and then say, okay, like how we can deliver these tools in a way that it is meaningful. Besides all of this, when it comes to healthcare, integration is a big point, correct? Everything has to be integrated in a way that it's not something else outside of the context. So this is important. So for instance, for hallucinations, when we started early on, it was like the early days of RAG. Like we said, okay, like can we leverage RAG in order to understand if this information in this piece of text is grounded? And then once we retrieve this information, can we have a system of other LLMs trying to score and evaluate this information? And you have seen probably this many times, correct? Now it's, like when we created it, it was like, wow. Now it's like a lot of like other solutions out there trying to do the same. But in most of the cases, they will be providing you like, oh, here is the reference. And by the way, thumbs up or thumbs down. Next slide. One more. One more. Okay, and this is what I'm referring to by integration, correct? We don't expect that the doctor is going to be able to go and like check every reference, correct? Imagine like taking a scientific paper and having to go through every reference. What we expect though is to create an interface that is intuitive and the doctor will be informed, correct? So this is what we are evaluating. Technically, we are trying to build a scoring system that it can be like an easy cue for like the doctor or like the user to like understand what is real and what is not. In some cases, the hallucination effect can be enhanced by other reasons. Like we have like the model, what data was trained on, what was the representation of the data, and in most cases, all of these things are like a closed box to us. We don't know what is inside there, and now you have like big vendors in healthcare offering these tools as part of the workflow without any guarantee or grounding. And this is the gap that we were trying to cover. Next. So now text is one part of the story, correct? You have imaging, you have pathology reports, you have a lot of other things that take place during like the examination, especially in complex cases. We are following the same example with imaging, correct? Imagine that you have a system that can generate a report text that proposes this report text to a user, and the user can just hover over like the report and see the grounding of like the phrases in the images. So again, like as you think about agents and how complicated systems they are, like at some point you have to account for like how this information is going to be presented and integrated, correct? So it is like really important if you have an agent that can measure like like the size of a tumor to have like the grounding capabilities. And we are keep building these custom tools. What is happening in some cases, like digital pathology, there are not many organizations that actually have digitized digital pathology slides. Matt, maybe you can tell me how big are these slides, correct? How many petabytes of storage. We need to like store them.
Yeah, the most recent transfer we set up was about 10 petabytes, 12 million images, I think. So you're typically between 800 meg and 1.5 gig on a per image basis for these gigapixel images.
So as you see, like we are positioned in a unique way that, like we took the decision, we made the investment to build the infrastructure to digitize the slides way, way before like Gen AI was like like the main thing. And now we are in a position that we have like not only the storage capacity, although it's expensive, we have the compute capacity to start building our foundation models, investigate what needs to go inside these models, how things should be structured in order to have like these models that we can use in practice. And I will hand it over to like Matt for like the last few slides.
Yeah, thanks, Panos. It's very interesting. He talks about the language, and I don't know if the slide was self-explanatory for you. Did it sort of make sense as far as the mechanism of like decomposition of the claims and then using a second LLM to score? Did that make sense a little bit? I'm seeing some nodding, so hopefully yes. So, and then in the vision modality, when you think about as you think about a collection of those different models that are doing grounded analysis across modalities. So you're taking the language of their electronic health record, the X-ray or radiology imagery, even other modalities, CT, MRI, things like that. You're bringing in digital pathology now. And Mayo has made, as Dr. Corfiata said, you've made an investment over many years to get, I think, 20 million slides digitized at this point, so an enormous investment, and have that available to the organization. You start to get these grounded capabilities that are really agentic in and of themselves, right? The process of grounding is an agentic process. Multi-LLMs, multiple calls, iterative checks and balances related to that. And then you're bringing them all together. So a lot of where we're headed right now is into multimodal models for specific diseases. You think about the image you have here, you're thinking about how do I take either germline or somatic genomics, take imagery associated with that disease state, whether it's biopsies or smears or X-rays of chest in this case. Work in cardiology has been tremendous, and artificial intelligence as well. Bringing all of them together and creating a fused story of that patient in terms of model, where each of the components of the fused methodology you have high confidence in. And that's ultimately the key, right? We can't have, our predictions are only going to be as good as the weakest link in that chain. So we really need to make sure that each of these is highly reliable and highly trustworthy when we're fusing them together in order to create these multimodal predictions. And that leaves us with 5 minutes, so right where we want it to be, to give you a chance to ask a couple of questions before they pull us off the stage with the big hook. So any questions we could answer? Yeah, there's a mic up here in front.
Thanks. Thank you. And thank you for being one of the first ones actually to call out the differences between vision and you're using machine learning and all. That's fantastic. We've had a lot of chatter about the way of working. Doctors, probably notoriously hard audience. So can you talk a little bit about getting all these things being used by doctors on iPads, on different surfaces? How'd you go about that? Who did you evangelize? Who did you make a champion? Just love to hear about that process. Thanks again.
Thanks. You want to start?
Yeah, I can say actually maybe the doctors are not the biggest issue. IT might be a larger one, but so like we have approached this in many ways, correct? We have like each department has its own embedded AI science group, and this will include people like me, data scientists, machine learning engineers, all working together to like educate as well create unique solutions on what are the things that products out there might not cover. I agree with you. They're challenging as long as you integrate things the way that the practice wants. I think that things are like very, very smooth. And this applies both on like external developed solutions and internal solutions. Everything has to fit a very optimized workflow. There is no time to like lose. We want to like be as quick as possible. And we usually try to like link in every theoretical aspect that we try to develop a clinical use case, and like not only on board the people that are familiar, the MDs that are familiar with AI. Let me tell you, some of them might be better programmers than me, but we try to onboard the people that are not so familiar well. So we try to like have a holistic view of what our practice wants. So this way we have like less friction. And again, education is a big part, correct? We are always working on education in every single aspect of like our like workflow to like make sure that everyone knows what they're using, how things are failing, correct? It's like really important to tell them this is what it is, what it says, and like it fails there, correct? It's important for them to know.
Just one more thought to add to everything, agree with everything that Panos said. It's really no different than any other application of artificial intelligence in some sense that I think what we don't get is a lot of second chances. Like get it right when you go in the first time, and you'll have a loyal customer in terms of the clinicians. There isn't a high tolerance for, oh yeah, it didn't work. I'll give it another try next week. That you have to get it right the first time. It's a very picky audience we're working with. So, okay.
Hi there. A few years ago, Mayo Clinic had a Dr. Greg Poland that was very concerned that a lot of the surveys and a lot of the big studies were being mischaracterized. Mm-hmm. Are there any plans to summarize or to take this all the things that are taking place in the wider world, being able to abstract that out and make that easier for people to understand, so that it's actually accurate and says true things? Or
yeah,
probably could have said that better.
From an education perspective, you're talking about like sort of
yeah.
So Mayo is, our email addresses are .edu, right? So this is it's an educational institution. One of the most visited websites in the world is Mayo's website from an educational perspective. I have not heard specifically a desire to go out and sort of take those studies and start doing validation against them. I don't know, Dr. Korfiras, if you heard different, but.
No, but we have a commitment to like share our learnings, correct? Like in venues like this scientific writing. So we try always to like share our learnings, bad or good ones, correct? We can share how we fail, we can share how we succeeded, and this is our commitment to education and research. If you see Mayo, we have 3 shields. One is like for like patient care. The other 2 is for education and research. This is what our 3 shields means, and this has been one of our like principles from early on. Thank you very much for the question.
And thank you. I apologize. They say last question. Please wrap up, it said. So I don't think I can take your question, but we'll be around afterwards as well. Thank you so much, everyone, for the opportunity to share.